Welcome to Lecture 10. And what we're going to do in this lecture is cover a second part of Chapter 14, which looks at the use of energy in transportation and electrical power, which are the two major ways today that we use energy. And this is an area, too, where we're looking at more alternatives to using fossil fuels in carrying out these functions. So this is going to be a brief lecture, and basically what we're going to cover is how is alternative energy used for transportation, what are some of the pros and cons of that, what role does energy conservation play in energy transitions, and what could drive a transition away from fossil fuels. So before we do anything, what we have to do is look at, first of all, our traditional transportation fuels, because this is a major way that we do things. And of course, transportation includes everything from cars and trucks and trains and airplanes and even ships, that we use to, for commerce and for also getting around. And we're going to see that when we start looking at fossil fuels, diesel is going to be a primary one, and so is going to be what we call motor car gasoline. And that just means your regular car, taxi, and small truck. This is mostly for commerce. Now understand, these areas are both consumer driven. So it is our supply and demand and our lifestyle and environmental footprint that determines this. And these are major areas that cities are looking into on how do we reduce individual or sometimes even commuter use of gasoline, and also how do we reduce shipping. Now the other thing includes jet fuels. This is a little different than diesel, but it's a separate type of fuel, and jets are not just for transporting people, but today a majority of the flights are for transporting cargo. And I have a flight app that kind of shows this on how incredible it is that most of the flights I see coming out of most major airports are the major shipping companies, and some, minor ones too. But we see a lot of planes going around, even including planes that do small shipments and ship medical samples when you go for a blood test. And then we're going to see that there's propane, which is used a lot, particularly in rural areas, and has very specific uses. Residential fuels, of course, and natural gas, which has limited use. And then electricity for transportation, which is a small piece of the transportation sector, and one that I'm sure Elon Musk wishes will grow a little quicker. Now, when we look at alternative transportation fuels, this is something we're going to see is probably going to be the best thing we can do to wean ourselves off of fossil fuels, is to look at more renewable types of fuels that we can make. The problem is there's going to be a consequence to that. Right now, the most popular one is ethanol, because we could mix it with petroleum to dilute the petroleum and reduce that usage, so at least we don't deplete petroleum as fast as we do. We can make ethanol from a variety of plant sources and waste sources, but the thing is that then that competes with other sources for those plants and materials. and ethanol could be used in a lot of ways for electrical production, again, to running vehicles. We look at electricity as an alternate to petroleum, but again, this is going to be a small market, and this electricity can be solar, so we can make solar cars, but there's of course a downside to that, like any solar, in that you'd have to find a way to collect all this charge during the day and then produce enough power to move big vehicles, but also be able to have a reserve battery to run at night or when there's not enough sunlight. Hydrogen, problem is we don't find hydrogen naturally. It is a byproduct of certain industrial processes. We can make it, but it involves energy in itself, so there's an efficiency loss. And we can reduce hydrogen-powered vehicles. A long time ago, I had a fellowship to go to Washington, D.C. and learn how to lobby for science, and I'll never do that again. But it was really funny. The agency, Union of Concerned Scientists, that sponsored us had a certain amount of money, so I had to share a hotel room with another person that was in this fellowship program that I never met. So I get into Washington, D.C. like at midnight, really late flight, and get to the hotel room. I didn't know if someone was going to be in the room or not. I know I had a roommate, so I knocked, and he immediately opened the door, and standing in his underwear was this old guy, and I'm going, what the heck? And he turned out to be, I found out talking to 2 in the morning with him. We forgot we had to wake up at 7 to be at the, talk to politicians and get training in that. But he was one of the developers of the hydrogen bus in the United States, which he couldn't market. And it was really sad because hydrogen is very popular in other countries, and there have been people promoting it here and using it really effectively in all sizes of vehicles. And unfortunately, he had to go to Germany and talk with Daimler-Benz to use hydrogen cells in their public transportation, and it worked. And now we buy that technology back from other countries. So hydrogen is a good potential source. Natural gas, the problem with natural gas is it comes from petroleum refining and from collecting petroleum. So this is going to be a fossil fuel, but we can make it. I mean, nature makes it. But can we make enough to fulfill our needs? And the same is true for propane. This is another byproduct of petroleum, but we can make it in labs. This is called synthetic chemistry, when you can make certain things for consumer purposes. But the problem is you have to have the raw materials and to be able to make them at a rate that is faster than we use them, or else it wouldn't be considered considered a renewable. If we can't make it fast enough, it becomes non-renewable or difficult to renew, which makes it limited, which means we got to conserve it, or it just gets very expensive. So we look at the data for transportation, because this is a major energy glut. That means a fossil fuel glut and other resource glut. It uses also a lot of resources in general, minerals and petroleum for the plastics and other things. But about 25% of our energy consumption in the United States goes towards transportation. And this is not true of other countries that are still at the stages, like you learn in the Hans Rosling video, of foot or car, a bicycle or animal transportation, or using small motorbikes. So we are big users, and particularly with large vehicles, and particularly for commercial transportation. Okay, and 90% of this transportation uses petroleum. Because I hate to say this, but the cars outnumber the trucks. And we use small trucks and cars very frequently. Okay. And what's really sad about this is that we still work in a mode in the United States like petrol is going to be there forever. And we don't look at cars that are very energy efficient. I mean, it's much better than when I was a kid. A car would get very, horrible gas mileage compared to today. So we are looking at some options, but mostly we still treat petrol like it's always going to be there. And the simplest thing we can do, which many cities are working on, is finding ways to reduce or replace. Let's replace individual cars with ride shares, which many people find inconvenient. In New York, they don't. In New York, we don't find public transportation inconvenient. This can replace hundreds of cars, and even find ways of reducing or making public transportation more streamlined and cleaner. So there are ways of reducing fossil fuel energy use and even reducing alternative energy use in vehicles. And again, this could be achieved by a lot of ways, but the major efforts that we see right now are traditional. We're not going to get away from gasoline and diesel and natural gas so quickly. So we have to find ways to replace it or to streamline and reduce its usage. So guys, when we look at alternatives to fuels in transportation, what we're looking at are ways of reducing our per capita and national use of petrol, I should say crude oil that we use to make these products. And what's really nice, if we reduce crude oil and divert it away from diesel and gasoline and jet fuel, we could put that for other purposes and reduce the cost of things that rely on that. So, I mean, we shouldn't, fall into the principle, wow, now we have this all available, like Javon's principle, and use this all up. What we can do is be conservative about other uses for crude oil too. So we'll look at this term called biofuels. This is usually going to be ethanol or some other type of fuel, which could be made from a variety of sources, the most common being corn and sugar cane, which unfortunately are for food. So this competes with the food market to use sugar cane and corn. In the United States, we promote corn. You get to the Caribbean and South America, they encourage, in Asia, they encourage sugar cane because it grows more readily there, and corn grows more readily here. We could also use broken down fats, waste fats from restaurants. This was very common in Europe. It's done today, obviously. But I remember in London, walking down the streets of London and then taking a cab ride and getting stuck in traffic. I was better off walking and being behind a bus that smelled like a halal fried chicken restaurant. It's like our Kentucky Fried Chickens. So it was funny because I'm thinking, man, I'm getting hungry. And certain cars, particularly the taxis, use these fuels made from restaurant fats, and they actually smelled like the food because you can't. It's a contaminant, but it doesn't hurt the gasoline in itself. So the challenge is, how do we use plant and restaurant wastes in a way that we could not raise the price of where those things would also be used, for the products that would also be used for, but we have to find a balance. And again, guys, we're still burning something. So remember, particularly on a test, we're still producing CO2, but these materials are cleaner, they're more controlled, and that is a problem because we do have to add additives that crude oil naturally has in it that we design our engines for. So we do have to redesign engines somewhat, and it does affect the powertrain in general and the output of the engines. I am not a fan of electric cars. Now, when I start looking at solar houses and other things like that, yes, but again, with limited, with a little hesitation. But the electric car is not going to be the future for a while. And a lot of it is the power they can produce, regardless of what Tesla produces. There's still going to be some efficiency problems. And we're not talking about cars that can carry a big load yet, or trucks that can carry, produce a lot of torque yet. I mean, this is being worked on, but the limitation is, the batteries. And these batteries get costly, huge. And so when we look at a gas car, the battery is very tiny. And look at these cars, and most of the weight is the battery. And these batteries are toxic. And they're difficult to recycle. In this country, it's almost impossible to recycle because they're considered a hazardous waste. So we ship them to other countries with less strict environmental policies, and it pollutes those people. But it's cheaper to send them on a ship, let people, including kids, recycle the compounds in this battery, and family-owned companies collect the materials, send them back to the United States, and we rebuild these batteries. So the batteries have to be rebuilt, discarded and rebuilt, and somehow hopefully recycled without producing a toxic environment. And it's very difficult to make batteries that are not toxic. Lithium-ion batteries, which are rechargeable, because they do produce a lot less waste than the standard alkaline batteries, is that it still becomes a waste that has to be disposed of as a hazard. Regular batteries get thrown in the trash. They're semi-hazardous, but not enough to require, special treatment. But we don't recycle these things because they're dangerous to recycle, and they're not built to recycle. People are looking at what we call product life cycle designs to make these more recyclable. And people are also looking at quantum batteries, organic batteries that age like us and decay like us, and all sorts of ways of generating electricity. Okay, fuel cells are a unique type of battery, in a way, if you want to look at that, or engine, if you want to look at that. And these are based on hydrogen power. Like I told you, I met the guy that helped to develop this technology. He was an engineer, and also had his own, consulting company on doing this type of stuff. These require a fuel, but it's a fuel that you can make from water and from other materials. Okay, and what happens is the hydrogen is forced to bond with water, and it creates water. So these buses produce steam. I've seen a couple of them in Germany and also in California, and they produce steam. The problem is you have to have hydrogen refill centers, and hydrogen is a gas that has to be compressed, and it can become dangerous. And it's also very explosive. I mean, the Hindenburg blimp dirigible was filled with hydrogen, and when it had a little spark, it exploded like crazy. So, and we talk about also hydrogen can be used to make bombs. So hydrogen could be expensive to make, not safe to store and transport. Now on a bus, I mean, you're just filling up a tank, and it's probably no more deadlier than gasoline in a tank, but it is more flammable, and we got to be careful with this. But these produce water as a waste. But the problem is now you have to recycle the water and use electricity to cook that water to make the stuff again. So you're getting an efficiency loss every time you recycle, the water from, let's say, a hydrogen bus, because you're losing energy and losing water in the process too. It's not 100% conversion. There is going to be some loss. So guys, there are other alternatives to transportation technology. You can burn chicken poop, you can burn potato waste. There's all sorts of things you can put into cars as long as the engine can process it. Okay, I mean, we had wood burning cars at one time and steam cars that you could burn anything, including a darn mummy if you want to do that. Was actually thought to be done at one time, as people tried that. So you can burn waste, whatever, as a fuel, but it could be a major polluter. It doesn't reduce carbon dioxide emissions, and it could also burn dirtier. But the thing is that it will wean us off of fossil fuels. So many countries are looking at alternatives, and much of that is driven by the expense of petrol and diesel, because a lot of companies pay a premium price for their gas, and our gas that we pay here right now is like 1/4 to 1/8 of what some countries pay, and I've paid a lot for gas. I know luckily the Bahamas didn't have many places to drive. When I did rent a car, it had like a 4-gallon gas tank that cost me 20-something American dollar equivalents to fill up. It was ridiculous. So we're looking at, many countries are desperate. We're not there yet because of the cost of their gas. And they tend to build smaller cars. They tend to streamline transportation. They have much better transportation plans than we do at reducing traffic jams, which is the major way that we waste energy and stuff. And you'll hear about that a little later. So we as a world overall, we're looking at this, and this is part of the United Nations Sustainable Development Goals that they're recommending, is to look at weaning ourselves off of petrol and using petrol for less, and eventually not relying on it at all, or using it for much better purposes than we're using it for now. Now, when we look at other types of energy conversion and uses, when we start using energy for electricity, what we call energy transitions, okay, is man, this is, what do we use to make electricity here? Coal. It is one of the nastiest things to burn. We used to use wood. It is also nasty. We could also use burning oils to do that too, or natural gas to produce electricity. When I was in the Caribbean, the town I was in Jamaica, and also one in the Bahamas, they had a diesel engine that produced electricity for the village. And it was really funny because every now and then it would run out of gas, or it would break down and we'd have no power for a little while. We used to joke that the person riding the bicycle, died and we lost our power. But and sometimes at night they just shut the generator off and that was it, which also meant sometimes it was difficult to flush your toilet, because a lot of times we had an electric toilet that flushed, so you were kind of stuck. Okay, so when we look at electricity, this is probably more difficult to control than we look at transportation, because we're so used to our infrastructure with power lines. And when we start looking at power lines in general, just to transport electricity from one point to another, long distances, you have to have a fair amount of power plants doing that, or you just pump electricity at incredibly high rates. It means hundreds of thousands to millions of volts through that line. And that takes energy to do that. We have to burn something, produce steam, do whatever to make that electricity using a turbine or some type of motor, which is what Tesla was involved in, not the car, the person Tesla, and also Thomas Edison, who Tesla worked for and then went into immediate competition with after Edison fired him and told Tesla he was a schmuck. So a traditional power plant uses some type of fuel to produce steam that turns a motor, and that motor is hooked up to magnets that then produces what we know as an electric current. Usually what we produce is DC, and we can convert it to AC. You can also develop an AC motor. That's what Tesla did. He modified electricity to be AC because AC could travel further distances without decay. If we went with Thomas Edison and used only DC, we'd have a power plant like every 2 miles. Whereas, I mean, I'm not kidding. And with AC, we could have a power plant every hundreds of miles, so to pump that electricity. So it's still a very energy inefficient way to do it. And what's bad about it is when we are producing electricity, we are producing heat that is wasted. And this is true in many facilities. So what we can do to our machinery overall, including automobiles, is we can try to trap heat that we produce with the running of power systems. And that even includes a power plant, anything, an office. And if we can trap that waste heat, we could use it to co-generate electricity. That means use it to supplement power systems, very much like you hear about people with solar cells that pump electricity into the grid. So we could use our houses as ways of co-generating, either through generators themselves or some type of energy efficient device, or using some type of renewable energy to supplement. This could also be dangerous because people that work on the power lines, they have to make sure that the circuit is really off, and not only from the electrical company, but from any other people that pump electricity into that line. So if you're going to co-generate, you have to have a switch that when the power goes off, your power does not get transmitted through a line. So co-generation is being looked at in lots of ways of supplementing the typical traditional fossil fuel electrical generation. Now, an interesting concept when we start using electricity, and this includes electric cars or anything, is we get an energy efficiency that for some reason we sometimes call vampire power. That means it's power that's secretly sucked off and we never get to use it. It's the power consumed by the devices, meaning lost to friction, lost to heat, produced by friction, and other things. So anytime an energy runs, some of the fuel that you're pouring into that machine is being lost due to the inefficiency of the machine and due to the effects of gravity and friction on any moving part. I mean, we can't avoid it except maybe in outer space, but we can't run all our machinery in outer space under very cold environments also. We have to deal with inefficiency of heat too. So this is a loss we're always going to deal with. And also, when you have an appliance plugged in, that appliance is sometimes running computer chips. It's doing other things to keep circuits alive or batteries charged in that system, or just keep circuitry going in general, that in itself gets sucked off. So when you leave devices plugged in, which a lot of companies tell you to do because that's what keeps the unit charged or running, or the electronic devices, the computers operating in that, or to keep the system warmed up, so when you turn it on or use it, it's always going to be ready. So when you unplug these devices, of course, they don't use electricity. So just leaving a cell phone plugged in past your charge, a computer plugged in, any device that you're not using, a radio if you still have one, it is using vampire power. That means this power just gets drained and sucked away. Now, another thing you're going to hear in more detail in this class, and we're kind of bouncing back to transportation, but it's also useful for electricity too, is make smart devices. When we use electrical machines, when we drive our cars, we are probably the most inefficient things to operate stuff. If we were to allow artificial intelligence to take over machinery, to take over jets, to take over cars, to take over trucks, to take over a lot of jobs, particularly in industry, when we look at manufacturing, IA could be made to run things more effectively. And you're going to see a video on this going along with this lecture. And this is an incredible thing to think about. is to have self-driving cars. Now, of course, these are out now, but and we do have self-driving systems in general, some of which are remote control, some of which are autonomous. That means they don't need a driver or someone to sit in a booth, running these things. We find out that we can get an incredible efficiency because we drive like maniacs, not just Texas, but a lot of places. Texas, I think, is kind of maniac or not, than many places, but whatever. So self-driving cars and self-operating machinery is going to be our future because it could streamline processing. And also now we're coming out with smart circuitry that can detect when things are not being done efficiently and are wasting energy. Now, some other ideas too about energy, because much of our electricity usage is used to air condition and heat buildings, depending on where you live. One or the other predominates. The way we build buildings today, and they're showing a greenhouse here, is that our houses act like heat sinks, and they're good at losing heat. So we build them in a way that they're not doing a good job of the environment of retaining heat or preventing them from heating up due to sunlight. So we are finding ways to turning what we call the greenhouse design of a house or a building to turn it into something that could actually use the building shape itself to divert sunlight away from it, or to help it lose less heat, or to allow it to cool when it's warm out. And this goes back to ancient technologies used particularly in the Middle East and in tropical countries where houses were designed to let air flow through it and designed in a way to prevent sunlight from hitting it directly or at a bad angle so that it causes temperature fluctuations. So we could build buildings that are stable, that don't require as much air conditioning to cool because the building is heating up from outdoor sunlight or from indoor bodies and electricity usage, because a lot of your appliances produce heat. We can make buildings that don't lose heat a lot, or we could vent the heat and control it. So these are all, again, ideas at reducing fossil fuel, but not really replacing. Now, in some areas, you could probably have houses with no air conditioning and heating. I know in New York, we didn't have air conditioning on the buildings. Now, they were hot days. We considered hot like above 80. 70 was really hot, but above 80 was scorching. And yes, it was uncomfortable, but we had flow-through windows that made it a little less tricky. Now, of course, in climates like Houston, that gets unbearable with the prolonged heat. But there are ways of designing things to be a little more energy efficient. So why are we not just dumping petrol and transitioning away from fossil fuels like tomorrow? Because it's difficult. A lot of it is human habit. And a lot of it is it would be too expensive to just tear down the old and build a new. And it would really disproportionately affect poor people and people in developing countries. So as long as we have market forces prohibiting us from doing that, we're stuck. We also don't have the infrastructure to do it. And we don't really encourage the innovations. We do, but we have to supplement it or produce subsidies for them so they could be affordable and so people would find it worthwhile to develop. Why develop alternative fuels if it's not going to pay off and we're not going to transition right away? We need better government policies, but mostly individual action. Sometimes individual actions and consumer actions drive the market and also tell the politicians what we want. Okay, and maybe we'll start seeing some changes. So it's not going to be immediate. We've been on fossil fuels for a long time and using the turbine type system of producing steam or using some type of direct heat to run machineries and to pump electricity. So in the time that I've been alive, I have seen this whole idea of economic forces affecting fossil fuel use for both electricity and transportation. And we call these boom and bust cycles sometimes. So I've seen gas shortages a couple of times in this country, sometimes in other countries. I've seen the price of gasoline drop and go up incredibly. At one time in New York in the 70s, I could not afford to fill my parents' company van. It had a 40-gallon gas tank. It was a work truck. We also had a station wagon that had a big gas tank, and we couldn't afford to fill it sometimes. We also couldn't even get the gas. There were shortages. So we'd have to, you know, we have to use public transportation to move small materials back and forth, or else pay somebody to do it, which was probably more than it would have cost for us to do it. So it's a very, these are natural cycles. And we see the automobile industry sometimes responds to this by making cars that are more energy efficient or less, so we're used to seeing fluctuations. And I remember watching gas go from 25 cents a gallon to $1, which now we look at $1 as cheap. At one time we got closer there not too long ago, but the thing is, it never affected its usage. We would have to incredibly change the price of gas to discourage us from using it. So when we look at these booms and busts, they're temporary things. They're sometimes driven by panic, by political events, by, other things going on and whatever. But these boom and busts sometimes encourage us to look at alternatives. But it also inhibits alternatives because the minute we're in a boom cycle, we don't pay attention to the alternatives. We go, life is great, whatever. And we're also seeing boom and bust in the alternative energy markets too, as they become, sometimes we wean them into a market and then we find out that they're not effective or efficient in that market. So we're going to be see cycling going throughout your lifetime on these sometimes unpredictable forces that determine whether they're going to stick with fossil fuel or be driven more towards alternatives. And again, this is going to be a boom and bust. That means we're going to see one group favored over the other over long periods of time. So guys, when we look at generating electricity, this is a problem because we have to be able to not only make electricity, we have to be able to store it and distribute it based on need and usage. So, probably the biggest driving force that's going to permit wind energy and solar energy to produce more than 25% of the energy that we're using now, which is actually pretty good. It's a few years ago, that number wasn't that big, is we really start looking at local approaches to producing electricity rather than regional or national. So we're going to have to look at more smaller industries that are providing local electricity, which is probably better because New York can't operate the same way as like St. Louis, and St. Louis can't operate the way as some small town in Kansas, like Emporia, Kansas. So, so when we look at local distribution, this is the only way we're going to see an increase in wind and solar, and maybe look at water or wean away from coal for larger cities, because once we wean away from coal, we could use alternatives for and it would be cheaper to use resources than for large electrical production. So mostly we're going to see a transition in the rural that's going to go with alternatives to coal and fuel burning to make electricity. But the larger production will probably be stagnant and we're probably not going to see many what I call green options. That means wind, water, whatever, for producing this energy. So there are many creative ways, again, of producing electricity. We have water power, hydropower, which I didn't mention in the previous slide, but because this is very regionalized anyway, but you still need a lot, you still can produce large amounts, like, for example, the Boulder Dam electrical plant in Nevada produces a lot of electricity for Los Angeles, which is a pretty good distance away, pretty good drive away. But not every place could have this kind of water. And plus you have to build artificial structures to retain a body of water powerful enough to flow through a dam, like a waterfall. I mean, literally like in Niagara Falls, which I visited a couple of times, you're using a natural waterfall, but that waterfall varies in volume. And also by tapping into the waterfall, you're affecting the environment. And, these things also wear out, these turbines. So again, when we look at, alternatives, they're probably going to be local, because you can't produce hydro in areas that don't have water or not near the volumes of water that we can produce electricity with. So there's all sorts of strategies for producing electricity. But the thing is, what we need to do when we produce electricity is we need to find better ways of storing it. And that means we're going to pump it, use it, and then keep pumping and storing that energy for later times. And we can also do what we call modulate. That means, at least in our area, there are peak times for electricity and there are low times. And that is not easy for power companies to keep up with. If we can just produce electricity at a stable amount, and during those low times, we produce more electricity than we need. During the peak, we produce less, but excess is stored in batteries. Power plants can run more efficiently and smoothly, and we sometimes won't have a usage crash where we tap into electricity faster than it can be produced. It shuts down the systems, and we sometimes have to cut off electricity to various places. Our college participates as in a plan where we will allow our electricity to be cut off so that housing and emergency areas like hospitals and businesses could have electricity, because we're more adaptable than they are at times. Just hold class outside or whatever, just deal with, no internet for a while. Unfortunately, no flushing toilets either for most of our toilets. So anyway, so this is going to take some creativity, and there are various ways to store energy lots of ways, many of which are not covered in the book. So I'm happy to say in the past 5 years, there have been many governmental actions that are supporting research and becoming models for how government should set the pace for encouraging alternatives or reducing our use of fuel for electricity and for transportation. And you go to places like in California, parts of Kansas, you go to New York, there are all sorts of, right now, sometimes unpopular regulations and laws and programs being set up to reduce energy because it helps everybody. And also we're finding out that it does save money. Now there's an initial cost to it. Like I know in New York, there's a plan to get rid of all gas-powered taxis. And guys, the people that drive taxis, they pay a lot for that thing, and they sometimes run marginal businesses. They don't make a lot of money a lot of times. And I know I've driven them for a while to get through college. So you have to provide subsidies for the taxi drivers to transition their cars, to trade in their cars or get a discount on buying an electric car. And sometimes we use traffic control too to reduce standstill traffic. So we tell taxi drivers, you can't go down this street when there's a jam and you have to find another way to get around or whatever. Or we pace taxis at certain times to avoid the jams, which is difficult on people trying to use those ride shares. So there's all sorts of policies out there that, again, are useful. But the thing is, these policies are going to be driven by market and driven by consumer attitudes. Because politicians look at consumer attitudes, they look at the market and they say, hey man, this is what people want, this is what works for our economy, and we're going to deal with it. But some politicians buck the system and say we got to get rid of this because it's killing us and it's not sustainable. So again, on a positive note, we're seeing that in the US, and this is really more consumer and market driven, not so much government, is we're seeing a lot of solar power now for industry and for home purposes. Industries are finding out that it's sometimes efficient to turn their roofs into solar cells. Now they might not be able to run a whole plant on it, but they can reduce fossil fuel use, and also if they produce excess of that electricity, they could actually make money selling it to a government municipality or a electrical producing company. So this is really kind of neat. The thing is that we need to do as consumers and as citizens is the way we vote in politicians is look at who that politician listens to, as far as lobbyists and advisors and the public, on how do we use energy, where do we get our energy from, and also encourage politicians to promote research in alternatives, guys, because it's politicians that vote on federal government that funds research. and entities that provide think tanks for these type of developments. So we do have a lot of power, but we have to voice it and make sure that they're reaching, the right politicians, and basically voting sometimes with how we use our resources and what we want out of our resources. So as the chapter comes to an end, like I mentioned previously, governments can provide subsidies. We can provide help. We can provide tax breaks and even just give money to people to do alternatives. Now, the problem if people do it on their own, if we start looking at forcing everybody to buy electric cars, the thing is that this is going to be beneficial for wealthy people. It's not going to benefit the poor who cannot afford to do this. So we'd have to pay the poor to do this. And we might end up giving them a car that might not be practical for them. Or, so there's going to be difficulty with this. Governments would have to spend a lot of money making these transitions. Middle class to wealthy people could afford these transitions. And what's terrible is we get the benefit of having cleaner areas because our cars are in the area that are clean. They have the electric cars, then blah, 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 blah. So, keep in mind that when we start making laws, we got to make them equitable and make it accessible to everybody and not just benefit the middle class and upper class. But look at how is this going to impact the poor, including poor countries, too, is how could they derive benefit from reducing fossil fuels and petroleum? And sometimes that means we're going to have to supplement them. But by sheer volume and numbers, their use of petrol and products is a major pollutant. And we looked at this earlier in the semester, is that just a sheer number of people outnumbering us, even though they use less technology, they're using older technologies and will be using those technologies in the future that produce a lot of pollution and greenhouse gas. And just a little end note, because your book focuses a lot on education and using college students, university students, as a way of indoctrinating you guys into looking at us, making the world sustainable for your own good, not because I think it's good or it's a socialist way of looking at things. It's a way that you have to think about your future. So we would host competitions, a lot of colleges do, to make their campuses energy efficient, everything from dorms to buildings. And our buildings are energy efficient and also water efficient. And we recycle a lot thanks to the environmental science students in the past who met with the college presidents at the time, met with the building engineers, and we actually proposed programs to reduce electricity, to do more recycling, to reduce the use of disposable bottles, and also to, make, buildings in general more energy efficient. So this is incredible. We also, at one time, I'm working with the cafeteria to produce less waste or find a way of recycling the cafeteria waste. So we have ways of doing this, and positive ways that can be somewhat competitive. So on that note, just think about how you can promote change and how your everyday life encourages the way we use electricity and transportation now. And I'm guilty of not being the best person at having or minimizing having a low environmental footprint. I'm slowly working at minimizing it, but I'm used to a certain way of doing things that are very difficult to abandon.